All right. Well, welcome back, everyone. This was a fantastic session by Luis just earlier. Thank you so much for that with transfer learning. And we learned a lot of things there, especially about deep learning and image classifications. But with us now, we have Daniel here calling in from Holland. How you doing, Daniel?
I'm fine. It's a nice weather here, so I just can get to enjoy the weekend tomorrow.
That's awesome. And you're a Microsoft MVP, right?
Say again, please.
You're a Microsoft MVP?
Oh yes, recently.
Yeah, trainer and speaker, and you've done 1,200 hours of developer training over the last few years here.
Yeah, I had classes with .NET students, beginners, but it helped me a lot to get into the details.
That's awesome. Fantastic. So can you tell me, like, how did you first come in contact with MLNet, and what's your story there?
Well, about 2 years ago, I had a presentation related to .NET Core on Linux. So I have used Raspberry Pi. And I realized very soon I cannot get too much sense from all this data from the sensors. So I tried to find something to do with this. But you know, the larger the data, the bigger the chaos. And my first thought was I don't want to go to Python or other platforms. And it was very new at that time, ML.NET, it was the version 0.3. So I jumped on it, and I'm very happy now because obviously I have found something in .NET ecosystem, and maybe that's why I'm here today.
That's awesome. And today you're going to talk about the Jupyter Notebooks in .NET, right?
Yes.
Awesome. Well, we are very excited to hear that. And as always, everyone on the stream today, you can ask Daniel questions in the chat or in the community Slack room. And I believe also, Daniel, that you are doing your own streaming on Twitch as well, right?
Yeah, I have left the slide some details about the channel.
Perfect. So people can kind of tune into your Twitch streams later as well to ask you questions if they have anything to follow up on.
Sure.
All right. Well, Daniel, the floor is yours. We are looking forward to it.
Okay. Thank you. Well, why this title? It's not related to the pandemic times, but it could be. Machine learning is as good as its data. That means a bad data set drives to a bad machine learning model. A good data set is better than a smart algorithm. And in other words, your model cannot be better than your data set. I'm not talking about only bad data, like reading errors or duplicates. Be very careful when preparing the data because your biases are encoded there, are left there. Let's say the DNA contains all kinds of biases we want to avoid. Well, Microsoft ML.NET, it's not another machine learning framework. When thinking of data science and machine learning, of course, Python programming language is making the rules. In addition to that, the existing frameworks like TensorFlow, Keras, Torch, you name it, are not easy to integrate with .NET projects. So worry no more. ML.NET is designed for .NET developers. And as developer, you have access to the entire life cycle of a machine learning model. You can prepare data, you can train it, validate, evaluate, and finally consume the model. Now, from bottom up, ML.NET is built upon .NET Core and .NET Standard, inheriting the ability to run on Linux, macOS, and Windows. And is designed as an extensible platform. Therefore, you can consume models created with some other platforms and frameworks, like TensorFlow, Onyx, CNTK, and more. And more later, I guess. Infer.NET is some other example. Microsoft ML.NET is more than machine learning. It includes deep learning and probabilistics and you have access to a large variety of machine learning scenarios, like image classification, object detection, in terms of extensibility. And we have a full arsenal here. We have API, of course, but in addition, we have CLI and UI, which is a model builder. We can use all of these in on daily basis when we are developing its API, but maybe in some DevOps scenarios, we might need the CLI. And of course, if we want to try something quickly, we can rely on a model builder. Actually, it's a very good start for a developer, because I want to let you know I'm not a data scientist at all, and for that reason, do not rely entirely on my interpretations. But from the code perspective, I really hope you will find out good information in my talk. So what do we have here? We have a flow which we will talk in the next slides. For example, talking about data loading, we have a data set. The data set anatomy, it's like a list of features, but one of the features is a special feature because it's the feature we want to predict. This feature is called label or target feature. All these rows with data are called observations, or let's call it readings. For example, we have a data loader, and this is responsible for loading the data from the external source. That can be a database, text file, or can be the memory. In addition, you can stream data while training without needing to load all the data in memory. And that's very cool, thinking of it like an enumerable being lazy evaluated. That means until you are hitting fit, the data are not there yet. And that brings performance, of course. Data view, it's a very important component of ML.NET. And it's a data set represented like something like a table with rows and columns. The schema of the data is there. The types of the fields are there. And very important, all the components are working with data views. Data loaders, transformers, savers, trainers, estimators, you name it, anything in the ML.NET are working with data views. First, I would like to talk about another way of seeing data, and it's DataFrames, which is not directly used by the ML.NET, but it's another object which is actually it's very new. I think it was released last autumn. It's very good to inspect, to visualize the data and find answers to questions like how many observations do I have, how many features, the types of the features, categories or classes, and very important, which one is the label feature. This is, of course, this is correct if we are trying to do supervised learning. In that case, we need a label. Well, do not look at this like something very rigorous. I mean, it's just to visualize by your eyes or run a few interrogations on this object. And let's talk about Jupyter Notebooks a little. This is very known in Python world. And recently, we have support for .NET Core kernel. Creating a model is an iterative process, and you have to experience a lot with transformations and trainers measuring and improving the model many times, or tweaking the hyperparameters. And during the process, you need to analyze the data again and again, ideally in a visual way. By the way, I'm a very visual person. I have to picture it to understand, and that's true with the coding as well. Well, Python, Jupyter Notebooks. It's a wonderful platform which we can now use with the .NET Core. First, I will explain just a little the real-world scenario which I have modeled here. We have a problem, and we try to find a solution. Let's suppose we have a system able to read data from sensors like temperature, luminosity, infrared, the daytime when they were created, and the distance to a source. Which source? The source which gives the heat and the light for the sensors. Well, and of course, let's hope we have at least a few hundred observations. These observations have to be labeled because we are planning to do some multi-classification. They have to be labeled. That means we have a feature called source in our problem for every observation. And actually, the source from the sensors is generating these observations. Now let's take a look inside Jupyter Notebooks and DataFrame before jumping further to more serious stuff. Maybe you are familiar with Jupyter Notebooks. I will spend only a minute here. There are some special commands. For example, lsmagic, which is listing the supported commands. Do not rely entirely on this. The list might be longer. And that's the command about, which is good to see if we are up to date with the latest changes. And for example, when we are registering a new object in the environment, we can interrogate the environment to see what kind of objects do we have. Or maybe we need some more information like the type of the objects. And then we can run whos command. And a very interesting feature which I have found here in ML.NET, because it's very new. It's object formatters. That's a very cool feature which is able to intercept an object which we are sending to the console, and it's formatting on the fly. For example, I have here a very minimalistic object named person, and then I'm telling to the formatter for every person, intercept and write to the console this content which I'm formatting here. Well, take care on this type. It has to be a concrete type. I'm having my biases here. I struggle a lot to identify why it's not working with interfaces. It's not. It has sense. And do not forget to control here the my type. We can just call the display command, or we can simply up there the name of the object. It's an interpreter, so it will be interpreted, but in our way. If you have problems, because debugging it's not very friendly, you can run the command log, which helps you get more information from the platform. Well, let's see a data frame and how this can help us visualize the information. And let's run a little cells here. And for example, I'm loading the formatter from an external file because if you are not careful, this notebook, it's getting clunky easily. A lot of information is very hard to control. So I have tried to do not repeat myself, of course, and I'm keeping my data in some external C# scripts. Formatters as well, because formatters are really ugly. I mean, there are a lot of lines there and not hard to understand, but hard to maintain. Well, the same, I had put my models inside another C# script file and planning to load from here and to not repeat myself. Let's go back to the Jupyter Notebook. I'm running these data frames here. As you can see, the data is loaded in a table fashion way. And we can see here, by default, there are only 10 records. You can set to see more, but be careful, you don't want to block your environment. And then you have some possibilities to see the information in a different way. This is very similar, actually. It's kind of porting pandas from the Python in .Net. When you're ready, you can convert it to enumerable and then import it in your data views. Well, let's get back to the presentation. We have here another chapter, it's data visualization, where I have invested some time to make the things nicer. And after I have read the information from a CSV file, I have split the information in training and testing data set. I have converted in a enumerable collection. Then it's time to visualize the data. Of course, data, when there are a lot of observations, it's not telling too much because it's hard to comprehend. So we have a few kind of investigating data provided by a very nice library. The name is XPlot, and you can see the data in a visual way. For example, we can see the categorical distribution to see how many samples we have for each class. It's very useful information. Or we can see how is that data distributed along the minimum and maximum values using numerical distribution. And very nice diagram, we have box plot segmentation. This is bringing more information, and we can see now very important information here. We can see which is the range of each of these features and how are data distributed. For example, we can see here temperature has a lot of outliers, which is not necessarily bad, but the mean values are somewhere around 20 degrees, which is normal. And for example, the distance, it has a larger range. I'm expecting this to have greater impact on the model, which I most probably don't want. And it's a first serious way to look over the data. Then it's another kind of diagram. It's named correlation matrix. It sounds cool. I jumped on it and to see what's that matrix. Well, you can see how are the features correlated one to each other, and maybe you already asked yourself if we really need all the features. This is a good way to see if we really need all the features, because most probably some are less important than others. And as you can see, we have here the range between -1 and 1 with the following meaning. Near -1 and near 1 indicates a strong relationship between the features. They most probably might be redundant. 0 indicates no relationship. That's fine. And close to 0 indicates, of course, a weak relationship. For example, in our case, distance and infrared are correlated. I will show you later in the Jupyter because I don't want to spoil it. But it's a good way to see how are these features really necessary for our model. Let's jump to the demo. I'm loading the models, initializing the context, loading the data, split it, take a look on it. You can use here DataFrames if you like. And then I'm trying to take a first look on the categorical distribution. And we have here some numbers showing us how many samples we have for each of this category. Or maybe we want to see the same for the testing data set, because the data not being balanced, it's a problem. We have to have a pretty balanced data set. So we have, for example, here we have almost double flashlight values. But in the trained data set, we have, it's again flashlight because they are in some other order. But anyway, we have to take care on this distribution. And then we can check for a histogram to see how our data distributed. But okay, I have this diagram for any single feature. But my favorite is the box plot segmentation. And we can see here the features, which doesn't seem to be very equally impacting our model. Most probably we might want to normalize this. Let's see the correlation matrix. We can see here in every cell how correlated are these features. Luminosity with temperature are highly uncorrelated. Then let's go to build a pipeline, because we need to do some transformations. For example, I'm getting the data and map the value to key, because machine learning, it's about numbers, and the categories are strings. So I have to encode that. Then I have a custom mapping, because I have realized I want to split my date time feature into hour and day. I think hour and day, it's much more useful for me than daytime. And then I'm concatenating the features, this is necessary when we have more than one feature into the building pipeline. And ML.NET is, by convention, is looking for this field, the field name features. And the last step in this pre-processing pipeline, I'm normalizing the features. Okay, this is important because I have planned to normalize the features, because I didn't like this plot segmentation too much. And let's see how would this look if normalized. Now they are normalized, much better. Now it seems like they are aligned. The impact is equally distributed. And now I'm expecting to build a model which not so many biases, let's say. But take care, we don't want to normalize testing data, for example. This is only for this pipeline for training data. Next, we are calling the trainer. I have used one of the trainers for multi-classification, which is, in our case, stochastic dual coordinate ascending non-calibrated very long name. And this is doing like linear regression. Actually, classification is a kind of regression. And then last step, post-processing, we have to encode back the numbers to the categories in order to make them human readable. And now we have the pipeline. Not yet the model, but we might want to validate the model against the data. And let's look how they are looking. I have called cross-validation. There are some other way of validating, but this one, it's very popular. And we can see what do you have here. It's actually it's the training data set. It's split it in folders, and each fold is in folds, yeah. And each fold is measured, and then it's made an average and calculated a standard deviation and confidence interval. Usually these data are not very friendly, so I have used a formatter in order to make them look nicer. So I have here the private static methods formatting these, and then let's check, it's right here. So I have intercepted this kind of object. We have here a list of cross-validation results of multi-classification metrics. This is what we want to be careful. It's our metrics here. And for that, I have iterated, and then I have prepared the data, assembled in a table, and send it to Jupyter Notebook. All this information is very easy to see in Jupyter Notebooks because there is a Pocket View API, which is an object, an API, able to render our HTML content. Let's go back to the presentation. And check the next step. So remember, if you decide to save time preparing the data, do not be surprised. You have to pay the price later. It's similar to technical debt. I would call it preparation debt. Well, we want to clean the data. Now we can use our instruments like DataFrames and box plot segmentation and correlation metrics, and we can decide which data are using or not, which data, yeah, and later which features, which is something completely different. First, when we got the data, we have the data, it's uncleaned. We will lose some data, which is called bad data, and then we are splitting the data in two. But after that, we can focus on building the pipeline. I have here with yellow map value to key, custom mapping, concatenate, normalize, the trainer, and then the post-processing pipeline, map key to value. For all this, for the pipeline, I'm using the training data view. Then at the end, I'm calling fit command, which is building my model. Once I have the model, I'm able to test my model against the testing data view. And when I'm using my model with the training data, I can do the cross-validation. And when I'm doing my model evaluation, I'm doing against the testing data view. And then we have another feature, permutation feature importance, another type of measurement. Let's check a little. So for model validation, the cross-validation, it's, as I said before, splitting in folds the information and sliding one by one these folds in order to calculate the accuracy for each of these. And then at the end, we are doing an average, and that's resulting in a general accuracy. We can examine the quality of our validation, inspecting the macro accuracy, micro accuracy, logarithmic loss, and logarithmic loss reduction. In terms of performance feature importance, we have this diagram, which is very important to see if we have some features which are not impacting the model. Most probably, we can remove, for example, day feature here, and our model will not suffer. Then it's model evaluation. Again, we can see here some metrics. We can watch some important information here. We can see here the micro accuracy. The closer the one, the better the accuracy, or logarithmic loss, which we are planning to lower it to 0 to minimize the value. And then I have the confusion matrix, which is a way to tell about data how many shots are correct and how many shots are false. For example, here, using the testing data set, we can make predictions and compare the predictions with the actual results, with the true results. In the previous diagram, we can see the day class was predicted correctly. In how many cases? Let's see. So day, it's predicted as day in 28 cases, but day it's predicted as flashlight in 1 case. Therefore, the accuracy is not perfect. It's 0.96. Do not expect the machine learning model to be perfect. That's not something very precise. This is why we are dealing with this matrix. And do not forget, when we are deploying a model, do not deploy without this matrix. We don't want a model and know nothing about it. Data preparation. We already did some part of this demo. I will go back and see the permutation feature importance. In the same time, we can examine the weights and biases. But now let's see the permutation feature importance. As we can see, they might be unnecessary, and we can consider in deleting it. Let's train the model, because we are switching to the evaluation, and the evaluation needs the model to be built. Let's display the metrics. And the confusion matrix, as I have explained in the slides. Of course, the more experience we get, the more we can decide. We can live without this, but we cannot expect to have a good model. The plan, the goal is to improve the model. So in time, we will be able to get the best from these measurements. But it's the first step. And of course, when we are done with this, we can save the model. We might want to save it in Onyx format. It's possible to do that. But we have to take care, because some of the estimators, not estimators, transformations are not supported yet. Like in our case, custom mapping, it's not yet supported, but maybe in the future. Okay, let's switch back to the presentation and see what's about the best part of this, the data. Data prediction, it's when we have the model, drop some input data, and make a prediction in output model. Let's see some demo for this. This is very short demo. Loading the model, the models, the data models, right? initializing the registering this custom mapping, which is necessary because I have used the custom mapping. This is a special thing which we have to take care. And then it's loading the model. What do we missed here? Maybe I didn't run everything. Let me run all these in the proper order now. Okay. Let me run again. The model is not created, so therefore the physical file is not there yet. This step is what we need. And now let's run again this. Okay, now we have the model, and let's make the prediction. We are preparing a sample, load some helpers if we really need. I have created the helper to put the data in a more friendlier way. And let's predict. The prediction says for a sample with 92 degree, no, it's luminosity, 92% luminosity and 122 degrees Celsius, 0 infrared and 0 distance at this time. Most probably it's a flashlight, but you can see here it's very close to lighter. It's not really a good guess. The lighter would be a better guess, but this is machine learning. Let's play with some other values. For example, 22. Flashlight, and that's correct. We don't have the heat anymore. It's a flashlight. Okay, let's switch back to the presentation. And what I want to tell you now, it's I hope these instruments will save you a lot of time and help you build good machine learning models. If you want to run notebooks on your machine or to reuse the formatters, I have invested much time in arranging those. Not very exciting, but useful. So you can get these already built formatters to use it in your notebooks. Visit my GitHub repository and grab them. And something else, I have a very new Twitch TV channel where I just starting to implement an end-to-end application with ML.NET. It's .NET Core, of course, with IoT, using deep learning. Actually, I plan to not label the data in a manual or semi-manual way. I will use the deep learning to label the data. I didn't try it. It's an interesting idea. So subscribe if you are interested. And usually I will do the sessions every Thursday. But you will see more data on the channel. Well, if you have questions, hit.
Well, thank you, Daniel. That was a great talk. You're getting some good feedback here on the chat here that I'm monitoring. Does anyone have any questions for Daniel? I have one while you're all typing. If you have any questions, I saw those awesome. We call them confusion matrices that you use in Jupyter Notebooks there with nice table formatting and so forth. You said you had those on GitHub, right? Was that correct?
Yeah, let me show you here. It's on GitHub. I just committed the latest. I will add more diagrams.
Yeah.
And I hope they will be useful. For example, for confusion matrix, this is specifically built for multi-classification. It has to be adjusted for some other classifiers.
And these Please
Yeah.
beat me to the question here, but the question I'm going for actually is, have you considered packaging this up as a NuGet package? Because I would love myself actually using them in some things I'm doing so.
It's a very good idea. Actually, my plan was to not let some other developers to get to through the same ordeal
Yeah.
and to share them. Very good idea. I will consider it. I will definitely. I want to do that.
Yeah, I would. I think that would be great. I know that the Samuel Brewer as well, that does Jupyter Notebook development, has also done some similar things. And I think a lot of people are struggling with confusion matrix visualization, and NuGet package would be very valuable.
He was my source of inspiration, but that his classifier was with true false for binary.
Yeah,
So then I have extended.
awesome. There's one question in the chat related to that NuGet package actually, and that's how do you add references in Jupyter, like external packages and libraries?
Well, it's a command named R from reference, I guess, where you can include. Let me get to like this one. This is the way we can include our NuGet packages. We are able to add some other NuGet package repository as well using the command #I. We have to put there a path to the other repository. But I think this is my response to the question. And then we just import the namespace with using.
Perfect. Yeah, that's very good. Thank you. All right. I think those are all the questions we have in the chat for now, Daniel. Again, thank you very much for this talk.
Thank you very much for having me. It was
Yeah.
great to be part of this.
Awesome. Well, coming up right now is an interview with Paul Mendoza, who is the founder of SigParser. And we're going to listen into his experience with MLNet in his organization and kind of what impact it has. And following that, we are going to listen to Bart Cernicki, who works for Microsoft as a principal architect, his talk about Blazor and MLNet, which I think is going to be super exciting to hear. So stay tuned. But first off, we're going to listen to Paul Mendoza. Hey, Paul, great having you today to talk more about MLNet and your experience with it. We're really excited to hear what you have to say. Could you tell us more about yourself, who you are, and what your organization do with MLNet?
Sure, thanks for having me on. So I'm the founder of SigParser with my co-founder Chris Landry. I've been a .NET developer